Go ahead.
Yeah. So guys, I think it's time to get started as we have only 1 hour together. So hello innovators, um, and welcome to Cappuccino Podcast, a podcast where innovation and technology leaders like you are invited to share their thoughts about technology, about innovation in a world where technology is evolving at the speed of light. My name is Ayub Kareem, for those who don't know me yet, but you're gonna hear about me a lot because we're gonna have a lot of guests around the world from different sectors of activities, innovation leaders speaking about their journey. And this if I can describe Cappuccino Podcast in 3 words, I'm gonna say interactive, insightful, and fun. Interactive because the audience will be speaking with us, interacting all along the podcast. Insightful because we have with us today two big profiles known by their expertise in innovation and technology. And I would say fun because we're gonna spend a good moment together, very, very far from the usual informal meetings. And you can see me, I'm not wearing a tie today. So we're gonna have it like a podcast in chill. So we're here just to have fun. And I would also say that it's gonna be unique podcast episode, not because it's the inauguration one, and not because I finally made my first cappuccino manually without buying it right up from Starbucks. Nope. But because I have the honor to have with me today two profiles that are working on technology and innovation for years, more than 30 years for each. Have with us Steve Rader, program manager at Center of Excellence and Collaborative Innovation. And for the other side, George, human computing interface technical discipline lead at NASA Engineering. Welcome, George. Welcome, Steve.
Thank you.
Thanks.
So first question first, Steve, you really know me since 2 years ago. So I will start with a tough question. Get ready for it. How are you today?
I'm doing great. Things are busy and the sun is out. It's a beautiful day. So I'm doing fantastic.
Perfect. What about you, George?
Doing great. Weather today is behaving. We have cool temperatures, which something in Houston, Texas, we always look forward to in the fall after a hot summer. So yeah.
Awesome. Here in Paris, I don't know what time is it in Houston right now?
It is 11 a.m.
11 a.m. because here it's 6 p.m. And it's the end of the day, I'm about to finish my cappuccino. And just after the podcast, I promise you guys, I'm going to switch to a beer or two. I'm looking to George because it was your joke last time. Okay, I'm so glad. I'm so happy to have you with us today. And I believe we're going to have fun. So first question first, I would love to hear more about you. How did you start the exciting journey with NASA? And let us know about you, guys.
George, you want to start? You're older, so I feel like I should let you go first.
My journey to NASA?
Yeah.
Okay, so there's a quote from a song that John Lennon wrote about his son. It was called Beautiful Boy. And in there it says, life is what happens to you when you're busy making other plans. And I have to say that I never thought I was going to come work at NASA. I'm going to keep this short. So I grew up in the I grew up in kind of a economically challenged part of Corpus Christi, Texas, and I had a family that had virtually no education. So, coming to work for NASA was something that I never really thought about. And I'll just like to fast forward. I worked various jobs over the years. Actually, my trade was a baker. I was actually a donut maker for many years. That's something that I learned at the age of 10. Um, Fast forward, in high school, I wasn't a very good high school student. I graduated the bottom 20% of the class. Um, After graduation, I was out for a few years doing all kinds of back-breaking work. Wanted to go back to school. That was a major challenge. I was able to get into a junior college, get my associates, and then transfer over to university at the university. And I kind of changed a little couple of majors and ended up in engineering. I was getting ready to graduate, and NASA came to to the university for interview. A couple of students declined. At that time, they used to call it cooperative education, and so they declined offers, and they opened it up to the street. So one opening was here in Houston. The other one was, I think, up in the East Coast somewhere, Goddard, I thought, if I'm not mistaken. And luckily, I did some electronics technician work while going to school. And also, even though NASA didn't initially want me as an intern because of my GPA, I was able to co-op at another company. And between those two pieces of, let's say, experience, got me the job at NASA.
Well, congratulations back to that year. I would say now.
Thank you.
I'm not sure I was born back. Congratulations.
Yeah.
I had not heard your story on that, George. That's awesome.
There's more to it, but that's the cleft version of it.
Exactly. Let's see. Mine's not. Well, it's different, but I grew up just enamored with space. I would dress up as an astronaut, and I would play astronaut, and I had rockets and the whole thing. And when it came time to go off to school, I had that was kind of my younger childhood when I was into space. And so I really wasn't thinking about any of that. And I was gravitating towards physics and engineering, and I couldn't really make up my mind. And I decided mechanical engineering. Everyone needs one. It's kind of a general purpose engineering degree. And so I ended up going to Rice University and really loved all of that. I worked for the Air Force for one summer on jet aircraft, and that was really interesting. And when it came time for graduation, I was looking for jobs, and I was actually looking in the oil industry and all over because I didn't have NASA on the radar. And honestly, I didn't think I was smart enough to work at NASA, and I felt that probably they only hired PhDs. And so none of that ended up being true, and they ended up coming and also recruiting at Rice. And I interviewed with them, and it was like a light bulb went on, oh, I could work at NASA? Yes, please. And so I took a job as one of the early flight controller teams for mission control for the space station. Really, even before space station existed, it was when the Space Station Freedom program was still active. And so joined and have been there ever since, I think coming on 34 years next year. So, yeah.
Wow. Exactly. So I saw in one of your interviews, Steve, that you've been one of those idea guys within NASA. And I'm asking myself how, based on which criteria NASA selects the candidates to be an engineer, for instance?
That's a really good question, because when I think of innovation in NASA, I think of George. I mean, George created one of the very first Siri type products, voice commanding on space shuttle, way before anybody else, and he was constantly coming
all the awards.
It's interesting. In most large organizations, idea people are not really welcome. It sounds counterintuitive, but normally you're working on a project with very specific things you have to get done. And if you're in a company, you're trying to make money, and so you're working on those projects. If you're at NASA, you're trying to get that rocket delivered on time, or get that spacecraft out, or operate safely. And it turns out that those things are actually antithetical to innovation, because innovation is disruptive and ideas are kind of, so whenever I would raise my hand and say, hey, what if we do this, all the managers would go, oh, well, we don't have time for that, we don't. And it wasn't until later that I understood those forces that have to be balanced in an organization in order to innovate. You have to actually take on some disruption, and you have to make a space that's okay to innovate. And NASA's been really good about doing that over the years. It's hard to do sometimes in an organization that also has to deliver.
Yeah, of course. And back to this time when you raised your hand and your manager was, damn, Steve is raising her hand. Is about to think outside of the box. Okay, we're out of the scope. So it is now things changed by the time. It is, and my question is it what you're doing today within the Center of Excellence in collaborative innovation that changed the things, or?
Yeah, so one of the things that our group is trying to do is to kind of recognize that the world has changed, and that the pace of change in technology, and quite frankly, not just the pace, but the scope of change has done. A lot of people don't realize, and I talk about this a lot in my talks, that the population increase and the education increases around the world over the past 50 years have resulted in an explosion of talent at the very same time that there's an explosion in technology. And so they don't realize that, for instance, 90% of all scientists that have ever lived on planet Earth are alive today. Like 9 times more than have ever lived in history. So when George and I went to school, all those dead engineers and scientists that made those textbooks, we have 9 times as many working. And the amount of technology that's out there with blockchain and 3D printing and quantum physics and quantum computing and quantum sensing and quantum computing, like it's just this huge bow wave of innovation going on. And so the result for organizations is a lot of disruption. Organizations aren't designed to bring on different experts from that many fields at that many, different places, changing that fast. We came up with a world where NASA would recruit and retain talent, and as does all other organizations. And what we're finding now is that's a very limiting model, because people can't have 32 different kinds of expertise. And the cutting edge out there is this very expansive horizon. And so one of the tools that we have found that is really effective at finding the technologies, finding the experts, finding not even the smartest person, but the person that can connect the dots between some other industry's solution and what we need, that those people can be found out in the world through crowdsourcing. And that's sometimes through crowdsourcing challenges. That's sometimes through freelance programs where you can find this freelancer you need and bring them in just for what you need. And so that's what our Center of Excellence does. We work with 50 different crowdsourcing crowds around the world that if you total them all up, represent about 200 million people. And we run projects for NASA and really projects all around the US government to try to help them understand these new tools and tap into those resources so that we, within the agency, within the government, can actually be the best innovators we know how. What I always tell our folks is we are the innovators, but if you're not starting with the best ideas and the best technologies, as your starting point to go innovate, then you're going to lag behind. So if quantum sensors is going to make you create a better sensor and you know nothing about quantum sensing, you better have a mechanism that helps you find that so you can actually build on those latest and greatest things. Sorry, that was a long-winded answer.
No. So it was cool because I was thinking that was a line with what you just said. For example, back to the project that I worked with you like in 2020,
Right.
Renault AI powered platform to generate promising technologies. It was connecting, and back to what you were saying, connecting dots, connecting the right technology with the right trend. And you guys, as technology driven profile firm, I think you serve the humanity with many technologies that are used today in daily life. And I want to give examples because there is a quiz in 10 minutes now. And I want to give gifts like this freely. So my question is, I always ask myself, is there a process or did you succeed to transform or find out another use case of one of your inventions without the usual process of spontaneous ideas coming out, like the man who invented the microwave because a chocolate snake was in his pocket. I don't know if we could figure out other use cases to a process, or what do you think about this? Do you have an example that you built together?
Oh, George, you're the inventor of the two. He's come up with all sorts of crazy, amazing things. I tend to use what other people have already come up with. But you go first, George. This is the hard one.
Yes, please.
Yeah, sure. I have to say, for the most part, you talk about, looking at other opportunities for certain innovation or inventions. And one of the things NASA has done over the years, especially in applying for patents, is looking at dual use. In other words, not only something that the space industry can use, but also in a commercial sector. And so I think that's actually a good thing, because in the past with NASA, and I'll give you an example. My former supervisor was involved with the first, let's call it telemedicine communication system for the Apollo space program. And so that technology was actually aimed at providing telemedicine information for the astronauts back on the ground as to the health and status of the astronaut. Well, later, as part of the transfer technology, as it's called, there were companies that took that technology and created these let's call it telemedicine systems for emergency medical technicians, where they can carry them on their in case there's a patient that's in bad shape, they can hook them up to a hospital and let the doctor assess the condition of the person that's injured. So it's that kind of technology that was first started out as NASA created this, but then it transferred over to into the commercial sector. And now we're looking at more so, when we're coming up with an invention, how we can use that both from a space exploration standpoint, but also from a commercial standpoint, that perhaps can create high-tech jobs. And of course, that's obviously something that every country would love to have, is very having a high-tech workforce, high-tech technology.
Exactly.
Innovation is the things that help build a very strong economy for a nation.
Yes. This is so clear. I would ask you, George, as you're working on human computing interface, I suppose there is a set of technologies inside that, and you're inventing. I'm not gonna say daily, but you're inventing with time. Do you try to discover, for example, other use cases with this in other sector of activities? I mean, not trying, but do you see any use cases coming out of these technologies. And while saying this, I'm thinking about diapers for babies, the composable diapers that have been invented by you guys. Can we imagine on the same table or round table where there is Pompers and NASA trying to figure out how we could invent and revolute the diapers?
Well, interesting enough, actually diapers are used for extra vehicle activities.
Exactly.
Um, but the thing about some innovation technology is it depends on the application. Certainly the area of human-computer interface. There's a lot of great technology out there. Steve mentioned about the involvement I was in and still am to some extent on voice recognition, speech recognition, and there's different what we call modalities associated with a human-computer interface. And we try to take advantage of the senses of the human, touch, face, rather the touch, smell, hearing, um, um, and try to come up with some solutions, especially benefiting astronauts in deep space missions. The deep space mission scenarios and concept of operations we're looking at
Mhm.
is going to be a very small crew, but yet that crew is going to have to control a very complicated vehicle. And so a human computer interface is going to be vital. In fact, the Human Research Program has identified, excuse me, has identified human computer interface as one of the challenges or risk associated with these space missions. We can't depend on mission control as we do right now because of the mission control. When they talk to station, it's only about a quarter second in delay. Even when we go to the moon, it's going to be 1 or 2 seconds. When we start going to Mars, it's going to get very, very long before they can communicate. So they cannot
Yeah.
depend on mission control to monitor systems, control systems. They're going to have to do it all themselves. And so the innovation associated with human computer interfaces with AI, hopefully quantum computing, things of that sort, are going to start coming to play. And but the thing is that sometimes, as one military person told me, cool technology does not equal efficient and effective solutions. You have to be very cautious about, having technology that perhaps could basically impede a person using a system. So we have to be very cautious and judicious on what we're looking at. So, but the whole thing about innovation is looking at different opportunities. Steve mentioned about the huge database that they have in terms of people out there. Brainiacs with all kinds of options, and that's the beauty of this is that you have so much data out there and different options, different ways of looking at a problem
Absolutely.
that you can come up with a good solution.
Yeah. And this is cool. And you see, guys, once we talk about technology, I mean, once we talk about innovation, we mention technology. Is for you guys innovation depend mainly on technology in today's world?
See?
Well, I mean, well, technology is a funny thing, right? Technology is simply the solutions we build upon to kind of make things better. And so it's a tricky word because it's a kind of an encompassing, but it is about like the solution, the performance, that how we're building on really building blocks. We're creating more and more building blocks that we're able to build on, which is one of the reasons for this tech explosion, right? Is we've built a lot of building blocks that almost anyone can use. Anyone can download, RapidMiner for free and learn artificial intelligence and machine learning and do it themselves. Like anybody can go and buy a 3D printer. In fact, you can buy a metal 3D printer for something like $10,000. That's crazy. You can go buy a gene editing CRISPR kit and do gene editing for something like $200, which should scare everyone. There's just
I have a 3D printer behind me, by the way.
Exactly. And you know, you can learn software, and software is being encapsulated more and more so you can use it. And so now you can, I think you can log on. I think IBM has a site where anyone can develop code that will run on a quantum computer, and you can try your hand at that. That's crazy, right? And so you're able to do more. And we're just building on the different things. So I remember when quadcopters came out and they first started really getting that stability in control. Well, now you can see everything that's built on that, and agriculture has changed, and photography and filmmaking has changed, and just the number of industries that take that. I saw something on bridge inspection. Used to be hundreds of thousands of dollars to inspect a bridge and keep it safe. Now it's a few tens of thousands to using a drone. So these things, I kind of have been fascinated with fireworks displays and how they're being replaced by drone clouds, where you've got hundreds of drones, and you don't have all the pollution. There's not the safety problem. There's not, and you can reuse it and do these amazing things, right? So we're just building on those things. I will say, for space exploration, this time delay problem that George is talking about is huge. In fact, I worked for a large part of my career on time delay communications. And it was funny, you were talking about connecting the dots. George and I worked on a program called X38. And on X38, we had these synchronized computers, right? There were like 5 computers, and they were connected with fiber optics. And they used this algorithm that Draper Labs had come up with that basically voted on all of the inputs and outputs using this kind of concept called the Byzantine generals problem, right? And so this ancient problem on how do you believe all these messages you're getting. What's interesting is a few years later, I was working on time delay protocol, what we call the disruption delay tolerant networking, DTN. And it's extremely important for deep space because it is this time delay tolerant and disruption delay, because we don't always have satellite links. But when it came to security, there was no way to actually distribute keys securely, because the way we had developed on Earth for networks was using time synchronicity. So being able to get a response quickly ensured you were able to securely do that. Well, we actually had this huge risk for the program, and we actually used crowdsourcing and said, look, we have this problem. We don't know how to solve it. We put it out there, and this crowd called Topcoder. They have about 1.5 million people on this one platform. And someone on that platform said, you know, if you use the Byzantine generals problem to fix, you can use that to fix this and establish trust without having time synchronicity. And we were like, wait, we actually used that over here, but we used it for voting our computers. We had no idea that same technology could be applied over here for security. And it took someone that was outside of our organization to actually connect the dots and point back to our own solution. So it's a fascinating kind of innovation that we had, but we didn't know it applied over here. And it took someone outside to help us with that.
And this is why the Center of Excellence for Collaborative Innovation. So what kind of I'm curious, what kind of innovators or external innovators you're working with? I suppose startups.
We work with everyone. And I will say the innovators are on both sides of the equation, right? The innovators are the ones who actually are willing to go put their problem out there and get input from others and try to discover better ways to do it. That if you're a good innovator, you're open to all of those things, and you're actively seeking what's the latest and greatest technology, what are people using in other industries that might apply to me, and you're going to start with that as your plate full of goodies to go innovate. And on the other side, on the crowd side, what we're finding is open innovation in these crowd platforms and these communities are really finding a way to tap into human capacity and human cognitive skills in ways that we never could before. What I've found out is everyone has something special, everyone. And we're finding ways that there are communities now that are using people that are on, on the spectrum with Asperger's or different cognitive disabilities that would never pass an interview, right? You would never be able to hire them because they just wouldn't be able to pass that. And yet these communities are finding ways to tap into people who socially might have a disability, but are brilliant at math or brilliant at data science. And they're finding ways to actually find ways for those people to contribute in real and meaningful ways. And this is happening. The key to innovation is diversity. And what we found in the traditional world that took hundreds of years to form is it was about weeding out diversity and actually trying to get sameness, but it wasn't focused on innovation. And now that we're having to change gears to concentrate on innovation, we're finding that the very thing that we were doing to make people all the same acts against us. And diversity, and I'm talking all aspects of diversity, cultural diversity, racial diversity, gender diversity.
Yeah, of course.
All of these things are important because each person's perspective, expertise, and experience all create a kind of a magic place where they can contribute. But you have to have a way to let them do that. What's really fascinating is we've been doing scientific research problems on these platforms. And we had one participant say, I actually do this professionally. I'm a researcher at a university where I research on this thing, but I'm working on a solution that I'm going to submit that my boss, the lab manager, would never have let me do. He would have let me create this because it's too risky. And they only have set amount of funds and time. And so they have to kind of go with the lower risk stuff. Well, where does innovation hide? In the high risk. It's in the improbable, right? And so this open innovation methodology starts to give people, and they don't have a gatekeeper keeping them from submitting, whether that's a boss or somebody telling them that they're not good enough or telling them they're the wrong color or the wrong sex. All of that melts away and everyone is eligible to come. And we're finding people that you never would have hired in a traditional sense for whatever reason, because there's corrupt gatekeepers or whatever, though it's opening it up to everyone. And so now we're actually trying to just encourage people to participate, because for so long, so many people were told that they aren't good enough or they're not smart enough. But we're finding that everyone has something to contribute, right? So I kind of went on a speech there. I apologize.
Yeah, George, you want to say something?
Well, I just wanted to mention about the innovation, and I think one of the things that NASA has done to try to get away from the let's call it the government slow-moving, slow-changing environment is to engage the commercial partners, because commercial partners are a little bit more innovative. They're a little more agile than the government sector. So we now have an opportunity to leverage from a commercial standpoint. People like SpaceX and other companies that are up and coming, Axiom, another one, is to leverage the their different ways of thinking, their divergent thinking, their processes that are more agile than the traditional government processes, to come up with solutions. Because, like, for example, going back to the moon, going back to Mars, is going to require a lot of innovation. There's areas and challenges. Steve didn't mention that I was a customer of his when we were looking at the graphics processing units that can handle the radiation environment in deep space. That is not produced right now from commercial companies. There's no money in it because commercial companies are in the business of producing the fastest machine they can for gaming, because gaming is the big thing. And so, radiation, building radiation, tolerant systems is, just something that it's not in their business model for producing. So we have to look at different ways of how can we produce a radiation tolerant system using commercial products, for example. And so, we this is where we have to take advantage of companies that Steve and company are looking at and work with, to come up with innovative ways of solving some of these difficult problems. The big area of in situ resource utilization, which basically, simplistically, you pour dirt into this barrel, and out comes drinking water and fuel. And that's very simplistic. But this is kind of things that we're going to need for the moon as a proving ground to come up with a solution for that and make it very reliable. So that way we can take that kind of technology to Mars, because we just can't transport all the water that's needed for a crew of four for 3 years. It's just not possible not at this point in time. So the whole area in situ resource utilization actually could be dual use technology. We could use it for space exploration, but imagine using a machine like this in the middle of Africa, where it's hard, where water is hard to find. And so a machine like that could produce water for some of the villages there that they have to walk miles and miles, to get water. So these are the things that are, that could be, they're possible with engaging the commercial partners.
Yeah.
Well, if I can add on to that, this idea of us expanding, if you think about it, 30 years ago, it was NASA, right? NASA was doing it. And then we kind of widened to international partners and started doing things there. And now we've got these commercial companies, which really have broadened the marketplace and the number of people that can be employed in the space industry. And now what I love about this open innovation piece is it really invites almost anyone in the world to help participate in some way on helping us solve hard problems and get out there and explore space. And a lot of people will write us and say, you made my dream come true. I actually got to work on the space program. And they might have just done a graphic for us or a little video or something, but they feel a part of the mission. And I think that is so important as we're going to space exploration, for humanity to feel a part of it, and that it's not this little exclusive club that's doing it. It's bigger and bigger circles of it. So I get really excited about that. So
this is awesome. George, you mentioned the access to water, and when you mentioned water, I remind me my first invention, which was a mechanism that helped to generate water in domestic life while saving it in domestic uses. And why I say this, it was because one time I was willing to take my shower, and I figured out that I should touch the water and check if it was cold or hot yet. And at that moment, I was waiting like more than 5 minutes, and there was a problem, not a usual problem. And then I figured out that there's a lot of quantity of the water that is wasting while waiting for its heat. And when I turned my head, I saw that there is a flush. And the flush, unfortunately, as you know, use potable water. And I was like, oh, I can connect these dots, those devices that give us water and those that are wasting water. And I figured out methanol, which is technology that could do this. And with time, that's why I'm interested today, 4 years or 6 years after, into innovation management, because I'm curious to know how, because this was typically a spontaneous idea that I had. So how do you guys, lead your inventions into the market? Is it a spontaneous way you generate ideas? Is there a more problem-driven ideas or more exploration?
Yeah, I don't know if you have a good answer for this, George. I will tell you, in my experience, dual use and spin-off technologies is actually a really difficult process, and it requires a lot of serendipity. We're actually working right now on trying to find better ways to kind of discover that. I was just at MIT Innovation Lab 2 weeks ago, and we were talking about this idea of in the basics of this innovation technology is this idea of need solution pairs, that for a need there is a solution that we end up pairing together, and that process is something we're still trying to understand. When you pick up a paper clip and somebody says, I need a solution for this, and you kind of take what you have and create sometimes, and sometimes you take from another solution. And what's fascinating is that we're actually learning a lot more of how to model both the problems and the solutions in ways with machine learning, that we may actually be able to use machine learning to harvest and make some of those connections. Now, we may be 10 or 15 years away from that, but it starts to give us some hope that these kinds of synergies, right, the something from one area that can help in another, are possible. Because right now you end up, each industry has its own lingo, right? Its own jargon, has its own understanding of its problems and its own understanding of technology. And so it can create a solution, as we can in aerospace. But if you're over here in agriculture, your lingo and jargon in problem space and solution space are all very different. So if I've created a solution that can meet one of your needs, how do I connect that dots? Well, I have to have someone who understands both of those. That's rare. And it's rare that they're presented that kind of intersection. And so we're trying to find a way that technology can help us with our technology, right? And it's not that will replace humans, that will simply amplify what humans can do, which is really kind of a fascinating area in innovation.
This is awesome.
Yeah.
I suggest. Yeah, go ahead, George.
Oh, I was just going to mention, as Steve was talking, I was thinking of MacGyver, and I'm not sure you're familiar with MacGyver, but MacGyver is a show on television, or at least it was, and so MacGyver always came up with a solution based on what was available to him all around. And take a bobby pin, a piece of chewing gum, a rubber band, and he could solve a problem right there on the spot. And I think about and here again going into deep space exploration. I envision that these astronauts are going to have to be MacGyvers, to solve some things that they have not trained on Earth for. And so AI and machine learning that perhaps potentially could help come up with a MacGyver solution, if you will, is going to be beneficial. And again, going back to the dual use, that could be beneficial here on Earth as well. Solving some really tough, complex problems that require a different approach. Again, the MacGyver
George,
approach.
I will add on to that. I think there's a real plug here for STEM education. That because if you go, I think MacGyver is great. If you look at what MacGyver did, is he knew a bunch of skills, right? He knew a lot about those materials and what the properties of those. If you, what I think is a clearer example is actually Andy Weir's book, The Martian, right? And in that, the Matt Damon character, he basically had knowledge about chemistry and physics and engineering. And whenever he was faced with a problem, he would start to actually methodically work through that based on his knowledge. And I will tell you, engineering training and science and technology, like learning, gives you the tools to innovate in ways that really we're going to outperform machines for the foreseeable future. But it does require the hard study of mathematics and chemistry and biology and physics, and really knowing how these things work together, because the universe is very complicated between materials processes and their properties physically, and magnetically. It's funny, you were talking about time delay and how that is such a huge driver for our automation for deep space exploration. Well, I was talking to one of our communications researchers the other day, and they are making real progress in quantum communication. Now, it's still probably a few decades away, but quantum communications is zero delay anywhere in the universe. Wow. And if that technology becomes a reality, it will change space exploration, because when you combine our ability to do telerobotics and really inhabiting a virtual robot, you basically would be able to, via robotics and zero delay transmissions, be able to explore anywhere in the universe that you can get to a robot to. That is a game changer, right? Now, it doesn't exist yet. Don't get too excited. Like, early TRL has a lot of speed bumps. But technology readiness is a hard thing to work on, and it's getting that technology where it's really used. It's very possible that technology will be able to send a 1 and that's it, and it doesn't have any bandwidth or something. But yeah, it's an exciting area.
This is quite good. And maybe one last question: is there all your technologies? Is the TRL apply on all your technologies? Like, it's a must to get it into the...
I mean, so technology readiness level is a scale from what, 1 to 10, I
9, I
guess?
think. Yes, maybe
9. And it basically, 1 is I have an idea. It has no basis in reality necessarily. And 9 is this works in its application, and I've used it, and it is proven over and over to work, right? And when you're working in space, gravity and radiation and potentially vacuum of space are all kind of unique environments that most things on the ground have not been exposed to. And so in the technology readiness level, you can have that on a terrestrial application, and you can work through those and prove things work in a much easier way than when it comes to space flight. And so there is getting something in a lab and getting it to where you can demonstrate it. That gets you to 2, maybe 3. Getting it to where you've actually produced it at scale and start to actually be able to produce it repeatably, then you're getting 3, 4, 5. It's not until you get to the 5, 6 where you've got to actually show in the environment that it can do, and then it's actually in use. And those are all really important, because reliability is hugely important. A lot of people don't realize it, but your car, it has millions of hours of testing and a whole heritage of parts. And one of the reasons they have racing programs is to actually accelerate the wear on parts and understand them better. So space, you're building one, and it's going to fly once, or hopefully more than once, but tens of times, not thousands and millions of times. And so getting something to be proven is an expensive and big deal. But this is where the commercial programs are really amazing, because it's scaling the numbers of launches. The other day, we had a crew splashdown, and I don't even think I saw a headline about it in the news. That's amazing. Not because it's not an amazing feat to splash down a crew. It's just part of the world we live in now. And having people flying to and from space is just no big deal. And that's the next step to making the numbers work to help us rapidly mature technologies as well, because it gives us more and more opportunities to get into space, to prove technologies and increase the TRL. George, I took all the time on that. Did you have something else like that? Because you've had way more experience.
No. I'm enjoying listening to you, Steve. I just want to add that the whole aspect of the commercial industry and flying into space, make it eventually viable for common folks to go up into space is not too far away. I mean, just think about back in 1903 for the first, I think it was 1903, 1910, where they flew the first transcontinental flight, and it took that flight took a long time because they had to land every so often to refurbish the vehicle and then keep on going. And so eventually, you know, now we fly all over the world, no big deal, right? And so eventually, it's going to be that way, like Steve mentioned, that you know, we're going to be going into orbit, we're going to be going into a orbiting hotel, and eventually, in time, you know, we'll be going to the moon and beyond. So it's a very exciting time.
I'm really excited if we could head to the moon. I would love to go to the moon, even if it's a dark place, but I suppose there will be projectors stuff. So I suggest to, I see that the time is running. I suggest to move to the quiz so we can involve the participants. Let me just share my screen. Yes.
Okay.
Can you see my screen?
Let's see. Yes.
Yes, perfect. So Cappuccino quiz is about who knows NASA's innovation better. And at this level, there will be 3 winners, but all of you are winners, I promise. That we're gonna see this. So the third place, you'll only have a t-shirt signed NASA. Second place, a t-shirt and a miniature of rockets. And in the last place, one bag signed NASA t-shirt and a miniature. But with quick touch, all of you guys will have a signed mug with Cappuccino. So I suggest that you participate by clicking into the link in the chat section. And not for you, Steve and George, because you're gonna get all the answer correct. So it doesn't apply for you guys.
And I just want to make sure I noticed you put it into the host and panelist chat, but you put it in the participant chat as well, correct?
Okay. Yes. Host and panelist. Let me share my screen.
I just know we can see it. I just want to make sure the participants can.
Yes, thank you. So please connect to www.count.it and tape the game pin as shown in the screen. Hello, New Geek. Hello, Mehdi. Moroccan PhD, okay. Mark.
I'm really liking these icons. These are great.
Yes, it's because of the Halloween. Michael. One other person we can get started. Okay, let's go. So, first question. What does NASA stands for? It's an easy one.
Never a simple answer.
Okay. It's absolutely National Aeronautical Space Administration. It's an easy one. Okay, Mustafa on the top. Next one. When was NASA founded?
I just want to point out I wasn't born. Had you been born, George?
Yeah. Oh, kind of a funny story about NASA. This is back when I used to communicate with vendors, and the lady told me, "Who you with?" I said, "NASA," and she go, "Oh, is that an island off of the east coast of Florida?" And she was thinking of. I go, "Oh, no, not quite."
So once again, Mustafa on the top. So the microwave, we said this, was originally invented by NASA. It is false, it is true. What do you think, guys? I think once we get 3 answers or 5, we're gonna skip, because I just said that it did a lot of time. Turning on. Okay, 6. Let's go. It's false, right? And which product now found in airplanes, car, and amusement parks, right, did NASA and scientists invent in the 1970s? It is the tamper plastic, the tamper foam, or the tamper glass.
I just hope it's the one I think it is.
It is the tamper foam. So the next question, it's about the tamper foam. So the tamper foam can return to its original shape after what percentage of compression? It doesn't depend on innovation, but it's good to know. Yes, it's 90%. Okay, we have Mika on the top. Congratulations. So NASA invented tang. I used to love tang when I was young. I was like eating it as a powder. And it was invented by NASA, do you think, guys? No, it wasn't by NASA. It was
I got a lot of people.
It was a decade before NASA existed. Mika, stay on the top. So NASA invented treadmill exercise machine that we found in every gym nowadays. It is true, it is false. What do you think, George?
What do you think, George?
Treadmill's been around a little while, but technology is used in space. Oh. You want me to answer that?
It is true. So why did NASA invent treadmill exercise machines? It is to keep astronauts warm, it is to decrease muscle loss, or to power scientific equipment. The correct answer is to decrease muscle loss because of the zero gravity. So we have Mika on the top. 3 last questions. The hook and loop fastener Velcro was invented by NASA. It is true. It is false. It was invented by a Swiss engineer named Georges de Mestral, not George Salazar this time. And it was a decade before NASA existed as well. Okay, we have 2 last questions. Which computerized process now used in the medical field was invented by NASA for the Apollo lunar landing program? It is the digital image processing, computerized tomography, or magnetic resonance imaging?
These are hard questions, I'm telling you.
Yes.
Yeah.
You gotta work on that t-shirt.
Everyone wants the bag. It is the digital image processing. Congratulations to the first 3 person. And the last question is a tough one. It's the before the last question. Why did NASA originally use light emitting diode known as LED chips? It is for growing plants, measuring distances, or testing astronaut reflection. It was for growing plants, exactly. So I'm surprised there is one person who answered well. So we're gonna discover there's some jump. Mustafa, congratulations. And the last question, this is a tough one. If you've been attentive to this episode, which center within NASA collaborates with innovators to generate ideas and solve important problems? It is NASA's Innovation Hub, Human-Centric Innovation Center, Center of Excellence for Collaborative Innovation, or Excellence in Innovation Hub. I think it's the last question, the green one. Congratulations for the 2 persons who answer well. And let's discover the 3 winners. So in the 3rd place, we have Ayub. He got the same name as mine. Mustafa on the 2nd place, and Mikael, congratulations.
Oh, nice. Congratulations.
Congratulations, guys. I will contact you after the podcast to do with us, to have your address so I can send you the goodies. So guys, I see that we are at the end of this podcast. I'm so happy. I can't describe my feeling. I'm so excited. I'm a little bit sad because this is gonna finish in 1 minute, but I'll be happy to grab a coffee with you in Houston in the next couple of years, who knows. So from my side, I am very happy, and I want to know if you have any last words before summating this first Cappuccino podcast episode.
I'll just say I've known Ayub for a couple of years now, and he has such an enthusiasm for innovation and making a difference. And I'm glad to see you're so entrepreneurial. You've gotten out there, I like the way you're encouraging people to really pursue engineering and STEM and exploration and innovation. So thank you for all of your work.
Thank you so much.
I appreciate you having me on. I've had a blast. So great to catch up with George.
Yeah, same here, Steve. And thank you for inviting me. This was great. I have to say that it was fun, as you mentioned. So I appreciate that. And for the students out there, I have to just kind of impart on them the aspect of perseverance is a key element. And even if you're inventing and innovation and you have setbacks, don't stop. Just keep going. You hear the word failure, and failure only occurs when you stop trying.
Exactly.
As long as you don't stop trying, you have not failed. So keep that in mind.
Thank you so much, guys. I really appreciate it, and I hope to see you again in another format, maybe on roundtable, another podcast on another topic. But I'm so glad to have you with us today, and have a great day, because for me it's have a great beer.
All right.
See you guys. Thank you so much.
Bye-bye.
And thank you for the audience.